Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC U1260, indicates a communication issue with the auxiliary transmission fluid pump in the Honda Accord models from 2017 to 2023. This fault is frequently associated with various electrical issues rather than mechanical problems related to the transmission. The auxiliary transmission fluid pump is crucial for maintaining optimal transmission fluid pressure, enhancing performance and longevity. Its location is typically near the transmission assembly, connected with a 4-pin 4P connector to the transmission control module, TCM. When this DTC appears, it usually signifies either a failure in the electrical circuit that could disrupt communication between the TCM and the fluid pump itself, or that the auxiliary pump might be malfunctioning. The purpose of this presentation is to explore the components affected and the systematic troubleshooting process to resolve the U1260 error code effectively. The U1260 DTC specifically points to lost communication with the auxiliary transmission fluid pump. The auxiliary transmission fluid pump has a critical role in providing the necessary hydraulic force for gear shifting within the continuously variable transmission (CVT) system. Located close to the transmission assembly, this pump substantially contributes to the efficient operation of the vehicle's transmission. It facilitates the flow of transmission fluid, impacting both the gear shifting efficiency and overall vehicle performance. The pump is connected via a 4P connector to the TCM, which is the brain telling the pump when to operate. Effective communication between these components is essential to avoid performance issues and to ensure that the transmission system works correctly. When the signal is disrupted or lost, the vehicle's performance can be severely impacted, leading to limp mode or reduced power delivery. The primary cause of the U1260 DTC is linked to an electrical circuit problem. Unlike mechanical issues, which can be ruled out, electrical problems typically include poor connections or loose terminals within the circuit that connects the auxiliary transmission fluid pump to the TCM. Such vulnerability can lead to intermittent or complete disconnection, hence the communication error. Additionally, if there are any breaks or faults within the wiring harness connected to these components, this can lead to a failure in communication. Assessing the integrity of these connections is vital for troubleshooting. Ground connections should also be checked, as any malfunction can affect the efficiency of the electrical signals required for operation. Other contributing factors may involve faults within the TCM itself or other intertwined electrical components. Symptoms associated with the U1260 DTC will typically manifest as noticeable transmission performance issues. Drivers may experience delayed or harsh shifts due to improper fluid circulation, resulting from the auxiliary pump not functioning as intended. There may also be indications of the vehicle entering a limp mode, where power delivery is restricted to prevent further damage to the transmission. A warning light on the dashboard related to the check engine or transmission systems will usually illuminate, alerting the driver to potential problems. It is essential to recognize that if the communication is sporadic, the symptoms may appear intermittently, making the diagnosis slightly more challenging. When troubleshooting, drivers may also report vibrations or noises that seem abnormal during gear changes, which should not be overlooked. The first step in troubleshooting the U1260 DTC involves turning the vehicle's ignition to the on mode. This allows systems to power up without engaging the engine, providing a baseline for checking electronic systems. Next, utilize the Honda Diagnostic System, HDS, to scan for any pending or confirmed diagnostic trouble codes within the Powertrain Control Module, PCM, or Powertrain Control Unit, PGM-FI system. The presence of additional DTCs, such as the P0A94 code for DC-DC converter performance, may direct attention to secondary issues affecting the auxiliary transmission fluid pump. This initial diagnostic data collection is crucial since it guides you to isolate potential failure areas, confirming whether the problem lies within the PGM-FI or other components connected to the transmission fluid pump. In the second troubleshooting step, it's essential to verify the operational status of the auxiliary transmission fluid pump. Select the electrical oil pump activation in the function test menu on the HDS. By activating the pump for at least 5 seconds, you can observe its immediate performance. Following the activation, again, check for pending or confirmed DTCs using the HDS. If the U1260 DTC appears, you have confirmed the failure. However, if it does not appear, the issue may be intermittent, indicating that further investigation is necessary. It's vital to revisit all connections and terminals for any signs of poor contact or damage, as these could be the underlying cause preventing consistent function of the auxiliary pump. For the third troubleshooting step, clear the current DTC using your HDS to reset the system. This will allow you to observe if the DTC reappears during further testing. After clearing the codes, switch off the vehicle to the off or lock mode. The next step involves disconnecting the auxiliary transmission fluid pump's 4P connector, which will temporarily isolate it from the system. Powering the vehicle back to on mode is essential, as this provides the necessary conditions for testing the circuit's integrity. Here, you will measure the voltage between specific test points in the disconnected state to determine if battery voltage is being present at those terminals. If voltage is detected at test points 1 and 2, you can conclude a potential issue is not within the power supply circuit itself, hence escalating to the next troubleshooting phase. Step 4 focuses on determining the integrity of the EOPSTS line, which refers to the signal sent to the pump, indicating operational status. Ensure the vehicle is once again in the on mode, while the auxiliary transmission fluid pump's 4P connector remains disconnected. Measure the voltage between test points of the auxiliary transmission fluid pump's connector terminals while connecting them to body ground. If battery voltage is present between the terminals, it indicates that the EOPSTS line is functioning correctly. Finding no voltage leads you to investigate further into the EOPSTS line, as it represents critical electrical feedback essential for the auxiliary pump's correct operation for transmission fluid pressure management. In the fifth troubleshooting step, the goal is to check for continuity in the EOPSIG line, which is essential for the signal transmission between the pump and the TCM. First, switch the vehicle to off mode and disconnect the TCM's 50P connector to ensure that no current is flowing through the system during testing. Now, check for continuity between the specific test points on the disconnected auxiliary fluid pump and the TCM connectors. If continuity is confirmed, it suggests that the EOPSIG wire is intact and functioning. However, if there is no continuity, it points to an open circuit that must be repaired. This step is crucial, as the EOPSIG line transmits the fluid pump's operational status back to the TCM, which is key in monitoring transmission fluid pressure and performance. In the sixth step, the focus shifts to checking if the EOPSIG line has been shorted to ground. This test helps to ensure that the circuit is free from undesired connections that could disrupt the flow of information between the auxiliary transmission fluid pump and the TCM. Again, set the vehicle in the off mode and maintain the disconnection of both the auxiliary fluid pump and TCM connectors. Measure continuity between the EOPSIG line and the body ground to see if any direct contact exists, which may cause a short circuit. If continuity is detected, immediate repair of the wire to eliminate the ground short is necessary. Conversely, if there is no continuity, it indicates that the EOP-SIG wire is functioning properly, allowing you to proceed with the next step in pinpointing the source of the communication error. At Step 7, reconnect all connectors that were previously disconnected during the troubleshooting process. Once reconnected, conduct a test on the auxiliary transmission fluid pump to verify its operational status. If, upon testing the pump, it proves to be functional, the analysis indicates that other areas must be investigated, possibly leading to external guidance or updated service information related to the observed DTCs or symptoms. However, if the pump fails the test, replacement of the auxiliary transmission fluid pump is indicated as the next appropriate action. The pump is critical for delivering adequate hydraulic pressure for smooth operation, and any malfunction can lead to significant transmission issues. Confirming the pump's status is essential to ensure that the DTC U1260 does not reoccur. The 8th troubleshooting step consists of checking if the EOP-STS line has been shorted to ground. Just like the previous checks, ensure the vehicle is in the off mode and that the TCM50P connector remains disconnected. The test involves measuring continuity between the EOP-STS line's test point and body ground. If continuity is present, it implies a short circuit exists. Immediate corrective actions should be undertaken to repair the circuit and eliminate any short to ground. However, in the absence of continuity, this would indicate that the EOP-STS wire is functioning correctly, therefore allowing further investigative measures into other components and potential failure points for the auxiliary transmission fluid pump system. In the 9th step, you will verify the integrity of the EOP-STS line by performing an open wire check. This ensures there are no breaks in the circuit that would lead to communication loss. As in previous steps, continue to keep the vehicle in the off mode with the auxiliary transmission fluid pump and TCM connectors disconnected. The continuity between the specific test points should be measured carefully. If continuity confirms a complete circuit, it suggests the EOP-STS wire is intact. However, any discontinuity signifies an open circuit requiring repair. Ensuring this line is operational gives confidence that signals from the fluid pump will reach the TCM, thereby playing a crucial role in ensuring proper fluid management, ultimately preventing the U1260 DTC from recurring. The 10th troubleshooting step requires checking the EOP-GND line to confirm if there exists an open circuit. Set the vehicle to the off mode. Using the multimeter, perform a continuity check between the designated test points of the EOP-GND line and body ground. This helps in determining if the ground reference, which is vital for the overall system to function correctly, is intact. If continuity is confirmed, the EOP-GND wire can be deemed healthy. However, upon discovering no continuity, it indicates the existence of a break in the circuit, requiring immediate repair of the wire between the auxiliary transmission, fluid pump, and ground location G201. This repair is critical to ensuring that ground references are accurate, as poor grounding could lead to communication issues and subsequent DTC occurrences. In this 11th troubleshooting step, the focus shifts to checking the fuse, specifically fuse number C3, associated with the auxiliary transmission fluid pump system. Fuses are essential as they protect the circuits from overload, and failure in a fuse can lead to complete system inoperability. Start by examining the fuse visually for any signs of damage or breakage, and also conduct further tests to confirm functionality. If the fuse is operational, reinstall it carefully and continue with the troubleshooting process. If it is blown or damaged, replace it and recheck the system operation. Continuous fuse failure signals an underlying issue that may indicate a short to ground within the circuitry that needs addressing before any further repairs can be successful. The 12th troubleshooting step involves removing the auxiliary transmission fluid pump relay for examination. A relay acts as an intermediary, allowing low current circuits to control high current devices such as the auxiliary pump. After removal, conduct a test to assess the operational integrity of the relay to ensure it allows the necessary current to activate the pump. If the relay fails this test, it means it cannot effectively close the circuit when activated, leading to the U1260 DTC being generated. In case the relay is functioning properly, the next steps will hinge on evaluating wiring or additional components in the system that may be causing inconsistencies in pump activation. Relays play a crucial role in ensuring the auxiliary transmission fluid pump receives power when needed, so validating their condition is pivotal. Step 13 transitions to checking the +B EOP line, which plays a critical role in ensuring the auxiliary transmission fluid pump receives adequate power. Begin by switching the vehicle to on mode while keeping the auxiliary fluid pump relay 4P socket and pump connector disconnected. Measure voltage individually from the designated test points to body ground to confirm whether battery voltage is available. If battery voltage is present at these test points, it suggests that the power circuit feeding the pump is functional. Conversely, if there is an absence of voltage, this indicates an open circuit within the +B EOP line, which must be repaired. Continuity and voltage checks in this critical circuit ensure that the auxiliary pump can operate under the optimal conditions necessary for effective transmission performance. The 14th troubleshooting step focuses on verifying the integrity of the EOP-RLY, EOP-RLY-CL line, which controls the operation of the auxiliary transmission fluid pump relay. Maintain the vehicle in the off mode, disconnecting the MCM 50P connector, the fluid pump connector, and the auxiliary fluid pump relay 4P connector. Testing for continuity is essential to ensure that the wire is intact and the relay can be properly engaged. If continuity is confirmed, it indicates that the wiring is functioning correctly, allowing the relay to operate smoothly. On the other hand, if you find no continuity, it suggests an open circuit requiring repairs. Ensuring this line is operational is crucial for the control of the fluid pump activation signal from the TCM, thereby impacting the overall performance of the transmission system. In the 15th and final troubleshooting step, perform a continuity check on the EOP-VB EOP-RLY outline to confirm its integrity. This line is essential as it connects the auxiliary transmission fluid pump relay to the pump itself. Maintaining the vehicle in the off mode, ensure that both connectors are disconnected while testing for continuity. If continuity checks out, it indicates that the EOP-VB EOP-RLY outwire is functioning effectively. However, if no continuity is detected, it reveals an open circuit that requires immediate repair. This step is crucial in confirming that the auxiliary transmission fluid pump can indeed receive signals from the relay, ultimately allowing for the proper functionality of the transmission fluid management system. Any interruption along this line may lead to the reappearance of the U1260 DTC and associated transmission issues. After completing the troubleshooting steps and conducting necessary repairs, the final verification process involves clearing any stored DTCs from the system using the HDS. Once cleared, conduct a thorough test drive to evaluate the performance and ensure no DTCs reappear during operation. This test drive is crucial as it allows you to observe any potential transmission anomalies that may suggest lingering issues. Pay attention to the responsiveness of the transmission and ensure that the auxiliary transmission fluid pump is engaging correctly during driving conditions. A successful test drive without the recurrence of the U1260 DTC will confirm that repairs have effectively addressed the underlying problems. If the DTC is cleared successfully and the vehicle operates as intended, this asserts that the repairs have rectified the communication issues originally experienced. To prevent future occurrences of the U1260 DTC, it is essential to implement a routine preventive maintenance program focused on electrical connections and wiring integrity. Regularly check all connections associated with the auxiliary transmission fluid pump and TCM for any signs of corrosion, looseness, or wear. Conducting periodic inspections of the entire wiring harness can help identify early signs of fatigue or damage that can disrupt electrical signals. Keeping the connectors clean and tight will greatly reduce the chances of electrical communication issues. Additionally, routine scans using the HDS during regular maintenance can proactively identify any emerging DTCs, allowing for timely intervention. Adopting these practices will enhance the longevity of the vehicle's electronic systems and contribute to smoother transmission operation. In conclusion, addressing DTC U1260 requires a systematic approach to troubleshoot and resolve the loss of communication with the auxiliary transmission fluid pump effectively. It is critical to verify each component involved, from checking voltage and continuity to testing the integrity of wiring and making necessary repairs. This comprehensive diagnostic process ensures that underlying electrical issues are properly identified and resolved. Proper communication is paramount in maintaining the performance and reliability of the Honda Accord's transmission system. Finally, implementing preventive maintenance practices can help mitigate the risk of recurring DTCs and associated issues. Through diligent checks and timely repairs, owners can enjoy a smoother, more responsive driving experience. Please like and subscribe to the channel. See you next time.